In the previous lesson, we looked at standard integration rules and how to use them. One of the things that we did was take each of the differential rules we learned before and looked at how each process is reversed to get a corresponding integration rule. If you notice though, we did not do product rule or quotient rule, and that is because there is no such thing in integration. When we get the integral of the product or quotient of two functions, we use an integration method called integration by substitution. Let's take this example. Suppose this is g of x. Make that f of x. And this is g of x. And we are going to integrate f of x times g of x with respect to x. How do we do that? How does the substitution method work here? First, note that this technique will only work if one of the functions is the derivative of a part of the other. Like here, notice that 2x plus 3 is actually the derivative of x squared plus 3. Sorry, x squared plus 3x. Let's write that down. F of x here is x squared plus 3x to the power of 4, and g of x is equal to 2x plus 3. If we let x squared plus 3x, if we make that u, then u equals x squared plus 3x. Notice that f of x now becomes f of u equal to u to the fourth. Now, because 2x plus 3 is the derivative of x squared plus 3x, g is then u prime, or the derivative of u with respect to x. Once we have established that one function could be expressed, one function is a derivative of part of the other, let's use what we have found out here to transform this into a more manageable, much more easier function. So now, x squared to the power of 3x, x squared plus 3x to the power of 4 is now transformed to f of u. 2x plus 3 is now transformed to du dx. And this dx will still be here. But you could sort of cancel it out. So we are able to come up with a much simpler expression. I'm sorry, it's just f of u du. And because f of u is u to the fourth, we now have an expression which we actually know how to integrate. From the previous lesson, we learned that the integral of u to the fourth is just u to the fifth divided by 5 plus c, which we could write as 1/5 u to the fifth plus c. And now all we need to do, the last step, would just be to put u back. So that's 1/5. U is x squared plus 3x, so that's x squared plus 3x power of 5 plus c, and this is the integral of this. Now let's take another example and show the steps clearly. First thing to do is check if one of the functions is the derivative of the other, and if you look at 3x squared, it's actually the derivative of x cubed plus 2x. So the substitution method could work. So let's go ahead and let u equal to x cubed plus 2x. So now du dx is the derivative of u, so It's 3x squared plus 2x. Oh, it's 3x squared plus 2. So we can now transform the given expression using this new information that we have laid out. But actually first, let's get rid of this radical symbol, the square root symbol. Let's rewrite this first function as x cubed plus 2x to the power of 1/2, 3x squared. Just copy the second one, 3x squared dx. Then let's transform it, because now x cubed plus 2x to the power of 1/2 is now u to the power of 1/2. And 3x squared plus 2 is now your du dx. And dx would still be here, but you can't cancel it out. So it's really just u 1/2 du. So we have now transformed this long and complicated expression into this very simple one that we actually know how to integrate, because then the integral of u to the power of 1/2 with respect to u will just be u to the 1/2 plus 1 is 3 over 2, so 3 over 2 divided by 3 over 2 plus c. Just simplify it this as 2/3 u 3 over 2. And the last thing that you need to do is to just put u back. Since u is equal to x cubed plus 3x, our final answer would be x cubed plus 2x, x cubed plus 2x to the power of 3 over 2 plus c. And you can leave the answer that way. You don't have to put it back into the root, the square root format. Let's try integrating a quotient. First step, check if one of the functions could be expressed as the derivative of the other. And as we can see here, 3x squared plus 5 is actually the derivative of x cubed plus 5x. So this could work. Let's make u equal to x cubed plus 5, and your du dx is this is x cubed plus 5x, this is 3x squared plus 5. Then let's transform this. Let's transform this into a simpler expression using these new expressions that we got here. So now we have, instead of 3x squared plus 5, that is our du dx. And instead of x cubed plus 5x, that is our u. So over u, then this dx will still be here. That looks a little bit complicated, but that's okay. It's actually not as hard as it looks. If you look at this and this, that's like du dx times dx over 1. So you could actually cancel it out. So when you cancel this out, we are left with du over u. Now think, is there a standard formula from the previous lesson that will work here? It turns out there is, because you could actually write this as 1 over u du. And the integral of 1 over u is just ln u. Just forget your plus c, and there you have it. The last thing that you just need to do is to just put your u back, which is x cubed plus 5x plus c. Now let's take an example that needs one more little extra step. So let's look at the functions. You have here x and e to the 1 minus x squared. Is there a part there that could be expressed as the derivative of the other? If we look at this, 1 minus x squared, the derivative is actually negative 2x. But we only have x here, so that doesn't work too well. But negative 2x could easily be manipulated to become x. All we need to do is divide it by negative 2. You will be able to turn that into x. So this could still work. Let's see. So we then will make u, let's make u as 1 minus x squared. So now your du dx, as we have seen here, okay, let me write that down below. Write it down below here. So your du dx is equal to negative 2x. So all we need to do is to divide it by negative 2, but since you have an equation, let's divide both sides by negative 2, or in this case, because we have a fraction on the other side, let's multiply both sides by negative 1/2. That's equivalent to dividing by negative 2. So now what's happening is you have negative 1/2 du dx is equal to x. So let's see what happens when we now substitute these new information into the original expression. So this will now become the integral of x, as we have seen here, is negative 1/2 du dx. E to the 1 minus x squared will then now become, because this is u, that will be e to the u. And your dx here will still be dx. We have nothing to replace it with or substitute it with. So it's actually working. A little rearranging will make this really simple, because if you remember a constant, you could just write it outside of the integration symbol. And then let's write e to the u first, because our format is always the function first and then the du dx part. So that's e to the u. And let's write this du dx over here. This dx is still dx, but you can cancel it. So see, we've simplified it as negative 1/2 integral of e to the u du, which we actually know how to integrate, because the integral of e to the u is just e to the u. This will be negative 1/2 e to the u, and just don't forget your plus c. And the last step needed is to just put u back. So negative 1/2 e to the u is 1 minus x squared plus c, and there you have it. That is your integral.